Today's lesson here is on slope fields, and for those who were with me in class last time before making this video here, we were working on this differential equation here, 3x squared minus 1, and well, it should ring a bell. Well, whether you were with me in class or not, let me go through this. So if we're going to integrate this derivative, right, well, what we did was we can multiply both sides by dx, and that would give you this. And that times dx, right? And then if you integrate both sides, well, when you integrate the derivative of y, you get y. And that's how you get your original function back. And we're left with this. We have the integral of this. Then we taught you a rule. We did the power rule there, or undoing the power rule. And we had this. This became 3. We left the constant. This was, you add 1 to the exponent, and you divide by your new exponent. Since our variable is x, that negative 1 becomes negative x. Don't forget your plus c. Then we did this, we saw this, they cancel out, and our original, or shall I say, general solution was this. Then I gave you I gave you a point, I say 2, 4, which I think was given in this fashion, right, in function notation. Either way, we know that x is 2 and y is 4, so what we did was we plugged it in, and voila, what we got was this. We got this function right here. We got f of x equals x cubed minus x minus 2. And then we were talking about how it could have been any of these functions. You know, the general curve of the cubic function here looks like this. And then depending on what that constant was, we'll determine where it's going to cross the y-axis here. And ours, because we knew we had this initial condition right here, 2, 4, we knew it was this black function. That is the particular solution. Now consider this. Originally, I gave you the derivative, right? We knew dy dx was that 3x squared minus 1 right here. Well, what if I gave you some x values and wanted to know what's the slope of the tangent line? We did that in the beginning of the year, right? So if I said, what's the slope of the tangent line? What is dy dx? Or what's the instantaneous rate of change when x equals 1, for example, right? Well, what we would do is we'd plug it into dy dx. And in this case, it's a 1, and you'd say, well, that's 1. It's 3 minus 1 equals 2. So that's a slope of 2. And then if you go over to the graph here, it makes sense because, well, remember, we're on the black line here. Well, I just colored over it. But I said when x equals 1. So visually, let's say we are right here, and I draw myself a little tangent line there, and it's positive, and, you know, I mean, I just hand drew it. But, you know, it could be totally 2, you know, up 2 over 1. Just to prove my point, let's just do a quick one more point. What if I wanted to do this? What if I want to find dy dx up here on the top here when x equals 0? All right, well, let's do the same thing. So we're going to do this. You're going to get 0 squared minus 1. So that zeroes out, and you have a slope of negative 1. Well, if we go back to the graph here where x equals 0, well, where x equals 0 is right here. And sure, down 1 over 1, that looks totally down 1 over 1-ish. Now think about this. Because the constant always goes away when you take the derivative, when you plug in these values, I don't care what your constant is, all the slopes are going to be the same here. They're always going to be the same here. No matter what point you plug in, regardless what the constant was, you're always going to get the same values on all the graphs, right? And if you start thinking of this, this is what a slope field is. It's just a field of slopes. All right. I mean, I guess you want a definition. How about a field of slopes, right? What we're going to do is we are going to create this, generate them. Okay, we'll keep it very small, low key, just a few points we're going to do. And then what we're also going to do is we're going to look at slopes, and we're going to try to identify what derivative goes with that slope field. Okay, we want to tie both of those together. All right, so let's get into it. Here we are asked to sketch a slope field for the given differential equation. Remember, it's an equation with a derivative in it. This is a differential equation. Then it says sketch the solution that passes through a specific point right here, 1, 1. Similar to the last problem we were just looking at, just different derivative and different point. Here's what we're going to do. We are going to draw ourselves a little table here so we can keep track of what these derivatives are actually going to be at specific xy points. So let's plug in some values. If I, well here, I'm sorry, I'm getting ahead of myself. Here's going to be our graph. So you may want to jot something like that in your notes. We're going to keep it simple. We're going to do, maybe let's do 4 points. Let's start with 4 points. And I'm going to say, let's do this point right here. We'll do 2 comma 1. We'll do 1 comma 0. Of course, we'll do this. Why not? What is that? 3, right? Let's do something down here. Let's do this one over here. Okay, let's just see what these slopes are going to look like at these specific points. So let's, so here, I'm sorry, let me identify this. We have -2, -1, when x is -2, -1. Then we have the origin there. I'm just going left to right. We have 1 comma 0, and then I gave you 2 comma 1. All right, so what is the derivative? Remember, the derivative is dy dx or y prime. Sometimes you'll see it dy dx, sometimes you'll see it y prime. You should know at this point they're the same thing. Well, we do this. We plug in, when x is a -2 there, that's going to give me a -4, but then when you have a -1 there, you get -5. Let's keep going. If you plug in a 0 here where the x is and a 0, well, that's going to give you 0 plus 0. All right, 1. If you plug in a 1 right here, that's going to give you 2 times 1, and then this is a 0, that's going to give you 2 plus 0. And I'm going to do 2 times 2 is 4, 4 plus 1, that's going to give you a positive 5. Well, let's see what these slopes look like. So -2, -1. This has a slope of -5, so, I mean, I'm hand drawing this, so I'm just going to make it look pretty steep. I know it's going negative, and I need to make it look -5. Basically, when you're drawing these, make everything look relative, right? Now, for the 0, well, zeros are pretty easy. So let's go to the origin, and at the origin, we have a 0 slope. What about the next one, 1 comma 0? We have a slope of +2. Well, +2 is not going to be as steep as -5, right? I mean, it's going the other direction, but just make it less steep than -5. And the 5, well, this one right here, at 2 comma 1, we have a slope of 5, so make it look steeper than the 2 you just drew, right? We just drew a slope field, okay? I mean, I only picked 4 points, but if on Delta Math, I think what they do is they don't give you many more. I think they give you like 7 or 8 or something like that. So you're going to just plot those slope lines, and same concept that was what we just did here. So you may want to do this on the side and keep track of some derivatives, because remember, these are the slope values at these xy points. I'd like to just fill this in a little bit more, so I'll do a couple more in a different color so it sticks out. So let me see if I do, let's do this one, -1, 1. I have -1, 1. Let's do something up here. Let's do 0, comma 3, and we'll do one more. I have room for one more. How about we'll do something over here? How about 1, comma 2? Okay, so we'll do 1, comma 2. And I'm just going to quickly plug them in. You can follow me here. That's going to give me a -2 plus a 1. That's a -1. 0 is going to be 0 plus 3. That's 3. And then if that's a 1, that's 2. 2 plus 2 is a slope of 4. So those are going to be this. -1, 1 gives me a slope of -1. So make it negative and don't make it as negative as your -5. The next one is 0, comma 3. We have a slope of 3. Well, make your slope positive and try to make it a little bit more than 3. I'm sorry, a little bit more than the 2, but less than your 5. And this last one here at 1, comma 2, we have a slope of up 4 over 1. So that gives me something like this. I mean, just keep it relative, you know, it doesn't have to be specifically perfect. It's your first time and we're hand drawing it, all right? Do your best. But it gives you, and once this is all filled in, what it does is it gives you a sense of what all the functions are doing. Like this one right here, you know, it might be doing something like this, and I'm not sure what they all look like, but, you know, seeing those few points, that gives me the sense it's doing something like that. Maybe because of this slope here, maybe it starts doing this. Maybe I haven't done enough points, but it'll start to show you the curvature of all the general solutions. And because I am no artiste, I do have, well, this is from the textbook, but I just want to make sure you see the perfect slope fields here. So if we were to do this, if we were to continue with points here, you would get all of these slope fields, okay? If I were to take a xy point and plug them into the derivatives, you'd give it all these derivatives, all these slopes. And you can even see what we started doing here with just a few points we had. This is exactly what it looks like. If you were to draw all the functions, it would all look like this. We were asked to find this one particular solution when x is 1, comma 1. Well, on the graph, you can see right here, following the slope lines, It takes practice, but if you were to see all these, it might be a little bit easier. And you would just follow all the slope lines and connect the dots that go through 1, 1, and then continue left and continue right and draw in your, as we called it, the particular solution, which also happens to be the solution to this differential equation here. Now that we went through that together by hand, I think it gives you a better sense of what this is all about. All right, so you're drawing a field of slopes, and you have different xy points, and you give me the derivatives there, and then it creates this field of slopes here, slope field. I want you to go into this assignment knowing how specific delta math is with your slopes. So what you're going to do here is, it says create a slope field, and what they do is they set you up. They give you the field here, they give you the certain points, and they automatically set everything. It looks like it's a 45-degree angle, so that's a good measurement, right? 45 up or 45 down, if you will, is going to be up 1 over 1 or down 1 over 1. And then from there you can accommodate or adjust what the slope should look like relative to the others. Now, what you're going to do is, you see these little points here, you're going to grab yourself, and you're going to grab that, and you're going to twist it around. You're going to move it around, and you're going to set it to what you want. It does not matter if the little dot is down, say you want to do a negative here. It doesn't matter if that dot is down here, or if you move it over here. It's just going to look at the line and see what the, if it's negative or positive, if you will. So what they're going to, you may want to do what we just did before. You want to set up an XY table, plug in what the slopes are there, and then make your slopes, and then submit it, see what happens, see if it accepts it. If not, maybe adjust what you think might be off. So I want to show you a level of detail they get, because I purposely went in there and I did one correct and I did one incorrect. I mean, I wanted to show you the level of detail. So this one is correct, okay? And look at what I did here. So I got, horizontals are easy. If it's 0, it's horizontal. If it's undefined, well, this one was undefined. Just make it vertical. And these two right here. So I was a little off. I made it a little steeper than it actually was. It shows me in red what it actually should be. And same thing down here. I made it a little steeper going down than it should have been. No worries, because I made it all relative to the other ones. Notice up here, I got full credit. Okay, I got the green check. Then I went a little bit further off than these two on the next example. So let me just show you what they considered incorrect. So you can see the X there. I got this one wrong. Well, I did a few of them correct. This one, wow, that's pretty close. Good job there. But I think this is the one that got it wrong, because that middle one still looks pretty decent. That's close enough. That would have gotten me credit. But this one's a little bit further off. It should have been a little bit more like this, and I had a little too steep, and I bet you it was relative to something else that I had there. And anyway, be careful. If it doesn't accept it the first time, adjust what you might, what you think might be off, and submit it again. But I think you'll get the idea after a few of these. We also need to be able to identify a slope field with what its differential equation is. So let's look at these three here together. We have 3 graphs, and I have given you 3 different derivatives, and I want to see which one is which. Well, here's the first thing I kind of do. We all know what zero slopes and undefined slopes look like, right? So if your y prime equals 0, you know it's a horizontal line. And if your y prime is undefined, you have a 0 in the denominator, then it's vertical. So I usually like to look at those first. So this sticks out right here. I'm looking at A, and I notice that no matter when x is 0, doesn't matter what the y value is, but when x is 0, we always have a 0 slope. So what if we were to see, so right here we know that this graph, the slope of the tangent line when x is 0 is always 0. Well, which one is always going to give us a 0 when x is 0? Well, this one might, we don't know what the y values are yet. This one will. And, well, this one only has y, so we're not really sure. I'm thinking it's this one. Let's take another test point and see what's up. What if we get more specific and we say this one right here? Okay, so we're going to look at the specific point 0, 2, right? Well, now, what is the slope of the tangent line on this one? Well, actually, this would be a parenthesis. Evaluated at the coordinate 0, 2. That would be the notation if you have 2 points. Well, let's plug in the 0 for the x, and we know that's a 2 for the now that gives us a slope of 2. This can't be that graph. You see what I'm saying? Because that's supposed to have a slope of 2. We don't have that. We still have a 0 slope. Let's try this one. What is the slope of the tangent line at that specific point 0, 2? Well, we only have an x on this on this derivative, so we only need the x point. So when you plug it in, well, bam, you get 0. And for this one, it doesn't matter what point you plug in. Let's do, how about 0 comma negative 2 down here? Okay, right over here. Well, you get the same thing. You only need the x, so you plug it in, then that one is what I'm feeling, right? Now let's just try the other one to see what happens over here. Okay. Now what is the slope of the tangent line? At our specific point, we were doing the 0 comma 2. Let's go back to that one. Now this one, notice how it only has a y. We don't need the x value to find the slope. We only need the y value. So you plug in the y value, that does not have a 0 slope. That has a slope of positive 2 as well. Therefore, I am certain that this one is choice A. All right, that goes with graph A. All right, so we've gotten this one. Ding. Since we went through the work of finding the derivatives at that point 0 comma 2, well, why don't we use that information and see if it, can help us at all. Let me do it this way. Let me circle the slopes here. So that's 0 comma 2. Well, it doesn't really help me too much because, well, remember the slope for that is 2, and the slope for this one was also up 2 over 1. And, well, those both could be up 2 over 1, so that doesn't help me. Let's pick a different point. Well, simply by looking, the next glaring thing that sticks out at me is, well, look at this graph. Notice how you always have a 0 slope along the x-axis. Well, no matter what, let me make that darker. No matter what your x value is, whenever y equals 0, you always have a 0 slope here. So that's pretty obvious. Let's work with that one, see if that'll help us. Let's take a specific point. How about we do this one right here? How about we do 2 comma 0 instead of 0 comma 2? So we're going to work with 2 comma 0 and see if we get 0 slopes. Because what this says is the slopes of the tangent lines at the point 2 comma 0 it's 0. Down here, what's the slope of the tangent line when you are at the point 2 comma 0? Well, remember the function over here was x plus y, so that's going to be 2 plus 0, and that does give you a 2. Oh, I think we found our answer, but of course let's confirm. Now on this one right here, so what is the slope of the tangent line at the point 2 comma 0? Well, remember this function up here was just y, so we don't need that. Hey, we don't need that. We only need the y value, and that, if we plug it in, gives us a slope of 0. I think we found our winner. And so derivative number 2 goes with graph A. Derivative number 3 goes with graph C, and derivative number I or 1 goes with graph B. Here's an example of what you're going to see for homework in Delta Math, and it's the same concept as what I just showed you. We're going to be looking at slope fields, and you need to identify which function goes with the graph. And in this case, what they do is they give you 4 different choices down here, and you have to identify which dy dx, which derivative goes with this graph. And I'm going to do the same thing. I would suggest starting with undefined slopes and 0 slopes. Those are nice and easy. And the first thing I notice in this graph given to me is I have undefined slopes whenever x equals 0. Right? That's one thing that sticks out. The other thing that sticks out is over here. Let me change the color to this. No matter what x is, when y is 0, whenever you have a y value of 0, you also have a slope of 0. So that sticks out at me, and that sticks out at me. Let's see what we can do with that. Let's take a test point. How about we do this one right here? How about I'm going to choose 0 comma 4 when x is 0 and y is 4. I know that I get an undefined slope, right? Whatever the dy dx is, the slope of the tangent line at this point 0 comma 4, that needs to equal undefined. All right, let's see if we can narrow down our search. So this one, well, so for this one right here, if you plug in a 0, you're going to get a negative 0 over, well, that's 16. Well, that equals 0, not undefined. Let's try the next one here. So when y, that's a 4, and there's going to be 0 squared. Oh, that's undefined. That's a choice. Maybe. Right? We've narrowed it down. Let's do another one. Here, if you would identify that you would derive that and you find it at 0 comma 4, that's the notation, well, you're going to plug in a 4, that's a negative 4, and then that might be a contender, that's undefined. Ooh, look at that. We have 3 of them. That makes that undefined. All right, well, we have to do another test point. Let's try this. So we know it's not the first one. Let's do, how about this one right here? I'm going to highlight 3 comma 0. Now we know for a fact that that has to give us a 0 slope. Let's see what happens here. Let me start by erasing this here to give us a little clarity on the next test point. Okay, so now we want to evaluate this slope at the point 3 comma 0, this one at 3 comma 0. I should do that, right? This one we're going to evaluate at 3 comma 0, and let's see what happens here. Well, this one we already knew this wasn't the answer, so let's see about the other three. This one, well, that is going to give us a 0 over a... now that's a 0, right? It could be that one. Let's try this one. So y is 0, there's a negative in front, and that's a 3. Well, that's 0 too, as well. And let me see the last one here. So if that is a 0, they all give us a 0. We are going to have to try something else. Let's try a different point. Let me erase this to give us some more room. And we know that we've narrowed it. The first one is not our answer. So I'm going to take another test point. How about I try 3 comma negative 1? Okay, we know that this one is not it. And I just said we're going to try this one here, 3 comma negative 1. It looks like it's a negative slope, not too steep, pretty small there. Let's see what happens there. So we'll evaluate this one at 3 comma negative 1, 3 negative 1, 3 negative 1. This one gives us a negative 1 over 9. This one gives us a negative 1 over 3. And this one gives us that's 1 over 3. So we said it's negative, right? So well, look at that. This is positive. So we now know that's positive, and we know that's positive. So it has to have a negative slope at 3 comma negative 1. So by taking another test point, you can narrow down the search. Hopefully you can get it on your third or fourth shot. But it's pretty straightforward. Take some test points, plug them in. Now for the big reveal to officially make sure we got the right answer here. Okay, it wasn't those two, and yes, we did it correctly. We got the right answer. Nice. Let's try one more here and make sure you got the hang of this over here. Okay, so let me get rid of this here. Delete. All right. This one. Select the differential equation that matches the given slope. All right, same question as before. Here are our choices, and let's do some test points. Well, let's see what sticks out at you. I see this. Let me do this in red. I see vertical lines here. It seems like whenever x is negative 2, we have undefined slopes. Another thing that sticks out at me is whenever y is 0, we always have 0 slopes. All right, so I might start there, and then let's see where that leaves us. All right, so in red, let's do the red first, the vertical. Well, let's evaluate this one. Oh, let's take a specific test point. How about we do this one? How about negative 2 comma 3? Negative 2 comma 3. So we have an x and a y value. Let's evaluate this at negative 2 comma 3, and this one is going to give us a 9, and that's going to be negative 2. That's 0 squared. That's 0. That's an undefined. Let's see what else here. So this is going to be that's a negative 2 for the x. That's 0, and then 3. Well, that's 0. That's not what we're looking for. This one, well, if you plug in a negative 2, so you're going to get negative 2 plus 2, and then the y value is 3 squared. So this is 0. That zeroes out. That's not what we're looking for. And how about this one? We're going to evaluate this one at negative 2 comma 3. So there's a negative in front. Oops, I don't need the double. I did double equals. Let's just do that. I have a negative in front. The y squared is 9. And then that's going to be negative 2 plus 2. Ooh, that's undefined. All right, well, we've narrowed it down to 2 of them, right? It's either going to be this one or this one. So let's take another test point, see what happens. I shall erase this like I did before. And we know it's either the first or the last. All right, so let's get rid of the middle ones there, and I'm going to take another test point. Let's do one on the blue line. How about I do here? Let's just keep it. Let's do 0 comma 0. Let's do the origin. I know that at 0 comma 0 we have to have a 0 slope. So let's see what happens here. Oh wait, yeah, this one at 0, comma 0, and this one at 0, comma 0. So that's going to give me a 0 over a 2 squared. Well, that's going to be 4, so that does equal 0. That might be our answer. And what about down here? So that's going to be y squared is 0, and that's going to be 2. Okay, well, that equals 4 as well. That's 0 over 4 as well. So we do need to take another test point. I thought maybe we could look out. Oh, first, not that it changes the answer, but there was a negative in front, but it's still going to be 0. Let's do another test point. I'll do, here I said green, so let's go down here and do something like this. How about, we'll do right down here. How about 3, negative 2? Okay. 3, negative 2, we know it has to have a negative slope. Let's just write negative there. Let's see what happens. Erase the work. See what we get. Evaluate this at 3, negative 2, and this one at 3, negative 2. We already know it's not that one or that one. I plug in, I get 4, I get 3 and 2 is, what is that, 5 squared is 25. So that's 4 over 25. Let's do the other one, see what we get. That's a negative in front, that's negative, negative 2, that's 4. And then we have a 3, that's 5, that's 25. Okay. Well, I think that gives us the answer because remember what we just said, we needed a negative slope, right? And this one is a positive slope. We found our answer, I think. Let's do the big reveal. Let's see if we've got the right answer. Ta-da! We did it right. Okay, so right there's the answer. I think you got the hang of this.